Hey, by the way, since we haven't taken notes in this class in a while, I guess I'm recording. I'll just leave it going. I don't care. Has any of you noticed that the dates for the last like 8 days have all been palindromes? Well, they're the same forwards as they are backwards. I first noticed it 6 days ago on my birthday when I wrote 3/21/23. Kid in my 7th hour pointed out, hey, it's the same forward as it is backwards. You see it, 3/21/23. Anyways, I got pretty excited about that. And then the more I thought about it, I thought the reason it's working is because the 3 is for the 3rd month and the 2 is the first number of the date. And then if you look at the back, the year 2023, the 3 and the 2 come in from right to left the same way the 3 and the 2 come in from left to right. Do you see that? The point is that it doesn't matter what the date is. Like it could be 3/21, 3/28. We had like 10 days in a row of palindromic dates. And so it's a pretty rare thing. Do you guys know when the next ones will happen? Obviously, it's today, then tomorrow, and then Wednesday.
Next year in April. Yeah.
Good job. Exactly. Good job. The next time it happens, good thinking, Luke, will be in April. Because if you think about it, the year will be 24. And so if we come at it backwards, we got to start with a 4/2 in the same way that the year will come backwards with a 4/2. So again, yeah, so 420, sorry, and then 421, 422, 420. So anyways, those palindromic dates are pretty cool, but we just happen to be like right now in the heart of a stretch of 10 of them, which is pretty cool. So anyhow, today, thank you, Kale, for not disappointing us all with that. And we got it on recording, so that's extra special. Good job. Way to go, bud. Okay. What's that, Kobe? No, it's all good. Oh, speaking of which, I got to pause this and take attendance. I thought I already did. Thanks, Dallas. Let's see. So sorry for the math lesson. I've been trying to do a little bit less math and more just practical stuff. And this is practical for the record. I'm trying to maintain that theme here, but this is the way that your money grows. And so I wanted to get this out for sure. We'll practice this today and we'll probably practice it tomorrow too. So what we're working with today is exponential growth. And I'm going to put a little comment in parentheses. We will also be doing exponential decay. So we're going to learn how the growth works first, and then I'll teach you how decay works. Decay is just like, when you're numbered. Yeah, it's the opposite of growth, right? So first off, there is a formula, and I'm going to show it to you very, very soon. But the way exponential growth works is this. Let's imagine that you had $1,000. And let's keep the numbers really, really simple. Let's say that you're getting an interest rate of 10%. And because this is not Algebra 2, we're not going to go heavy duty into the forwards and backwards and the little microcosm-y kind of stuff. We're going to stay real once a year interest, stuff like that. This is easy math. So I picked easy numbers because I wanted us to not need a calculator yet. We will need them soon. So if I had $1,000 and I got 10% interest, how much interest would I get? I'd get $100. Yeah. 10% means a tenth of something, and a tenth of 1,000 is 100. So over here in blue, I'm going to say, okay, so I would get $100. Now, what happens is that $100 goes back in to my balance. And what is my new balance going to be? No, remember, we're going up. It'd be 1,100. It'd be 1,100. Oh, no, this is like an invested. I'm sorry, maybe I didn't say that. So this is like we're getting interest now. So what happens now is after that, you get that interest one time, you get 10%, you get $100, it goes back in. But why this is exponential is that now our interest is going to be based upon the new balance. And so we're still, I think, in no calculator mode. What's 10% of 1,100? So again, I get another 10%, but now it's $110. So I'm going to add $110. Is everyone okay with that? That the 10% is being based on the new balance in the account, not the old. Good. Okay. And so now the balance is 1,210. Does that sound correct? Because that's the balance plus the blue number. So white number plus blue number.
10%.
So again, I get another 10%. And now it would be $121. Are we still here? Because if you're lost already, then this is kind of a waste of time. Everybody okay? So we just keep taking 10% of this and we keep adding it back in. And we haven't needed a calculator, I don't think, to this point. At some point, very, very soon, we will. So if I do another, if I add my 121 back in, what's going to say it again? Nice job. And so now I'm going to take another 10% of that. And how much do I get?
$433.
$133.10. Very good. 10% I thought would be easy for us because you just move the decimal one place to the left. And this is where it starts to get a little bit annoying. And so if I add that back in, my new balance is 1,464 and white number plus blue number. White number plus blue number. Old balance plus interest added equals new balance. Got it? Kale, you okay with it?
Yeah.
And this is now where we've entered, I think, it's starting to become uncomfortable zone. It usually takes about 5 years with this basic example for it to get to the point where we go, yeah, I'm peacing out. So if I take 10% now of my new balance, again, just move the decimal one place to the left. How much do we add?
$146.40.
$146.41. Again, please, 10%. I picked it on purpose. Just move the decimal one place to the left.
Colby, if you can't
Still okay? And we can keep going, but I don't want to. I want to stop now because we've entered the discomfort zone. However, just stop for a second and think right now about how you would feel if I said to you, I want you to do this for 50 years. Because by the way, that's a very reasonable ask for the real world, is to say, I want this to grow at a rate of 10% and I want it to do it for 50 years. I'm sorry, but we just did like 5 years and I'm already over it. You know what I mean? Like after this, then I got to add that back in, and then I got to take 10% of that, and then I got to add that back in. Imagine doing that process 50 times, especially considering now how long the decimals are starting to get, right? So I'm going to put a formula up on the board, and I want you to just know that I want you to appreciate the formula just from the perspective of how bad this would suck if we didn't have a formula. Got it? Okay. So again, I'm giving you one version of this formula. I promise, unless you want to, we're not going to do anything fancier than this version of exponential growth. If you ever want to, you can let me know and we can go down that road. But for now, here's your formula. You should write that down. And it's super simple, provided that you have a calculator. Just write it down. So this is I'm sorry, I should read out loud as I write. This is A equals P times, so in parentheses, that is 1 plus R raised to the power of T. T stands for time. And time in this case will be the number of years because we're getting interest once a year. So far, so good?
Oh, yeah.
So if we were doing, by the way, we should, if you're taking good notes, let's write some stuff down. P stands for principal, but because people always get the spellings of principal and principal mixed up, I just like to call it my starting amount. So whenever you hear the word principal in the real world, that's like your initial balance. So like if you go and take out a loan for $10,000, that's the principal amount of your loan. Got it? Or like when you pay off your house or your car, there's always that principal balance. Is like, where did it all begin? All right. Do you guys want to guess what R stands for?
Retail price.
Nope. What would it stands for rate, but when you say return, I don't disagree with that, but it won't really apply all the time. So R stands for rate. And in this case, it's rate of growth. Here in a few minutes, it's going to be rate of decay. And I might just save decay for tomorrow. Let's see how this goes for now. And then, of course, T stands for time. So those are the only, obviously A stands for like, it doesn't stand for answer. I wish it did. It's like the final amount, if you will. So in every problem, there's like a where you start and then there's a where you end. The where you end is the A value. So let's take a look at our problem that we just did. Yes. So if we were going to do our problem from just now, our starting amount would be 1,000. What would our interest rate be? Now, 10% is 0.1. And I can tell you from doing a lot of this with Algebra 2 that one of the most primary mistakes that they make, even when it starts to get really, really complex with like logarithms and everything, they still sometimes struggle with moving decimal points. So just think about the number 10%. The decimal is currently right here. You see my big blue decimal point? Always move it 1, 2 places, and that's where I got 0.1. Your rate has to be a decimal or this won't work. Good. And then in our case, time is sort of flexible, right? So let's just take one for a spin. If I go back and I look at our examples, this was year 1. This was year 2. This was year 3. And let's do year 4. Let's just check it to verify that we get the same answer using our handy dandy dope little formula as we did when we grunted it out and did 1 year, then 2 years, and then 3 years, and then 4 years. So let's take this formula for a test drive. And this is where the calculator is officially now just mandatory. So in our case, in our example, let's do t equals 4. So the way this looks on any standard calculator is you're simply going to type in 1,000 times 1 plus 0.1, and then you're going to close those parentheses, and you're going to put the power of 4. And I really consider part of today being a success. When I look back today and try to decide how did we do today, a big part of that is you functionally put these in your calculator every time. So grab your calculator, let's practice. Your answer should match what we just put in our notes for the record. Your answer should be 1464.1. Can I see your calculator screen? That's, so Kale did not use to the power of 4. In case you guys are wondering, on your TI 30s, like if you're borrowing one of mine or if you have your own, you guys have to do this button and then 4. That's how you do exponents. On a lot of other calculators, there's actually like a little X to the Y button. It's just to the upper left of the 7, usually, if you're on a TI 30. It's called a caret, CARAT, I think. Do you see it?
Yeah, I know. It is a TI 30, but I don't think it's a. Yeah, it's a different TI 30.
Oh,
It's this button right here.
Oh.
So yours, we don't ever want to use this again. Is this your calculator?
Yeah.
Okay.
So I use it over here.
Oh, I want you to borrow one of mine. This thing actually does more harm. Did you get it?
Mm-hmm.
Good. Everybody get it to say $1,464.10. It should say 0.1, and now it's your job in Moneyland to understand that 0.1 means 0.10, which means 10 cents, right? Mine won't say 0.10 either. It'll say 1464.1. Anyone still having calculator issues? Okay, so now let's put this to practice. What I want to do now is I want to figure out how much that $1,000 investment will be worth in 20 years. So I want you to practice, type it in again, please. So again, what you're going to type in will look like this. On most of your calculators, it's going to say 1,000 and then parentheses 1 plus 0.1 to the power of 20. 20, please. So after 20 years, you should have $6,727.50. That 49999 would round that up to 50 cents, right? Okay, let's do it for 30 years.
And the first one was 10 years, correct?
The first one was 4, actually. Yeah, I don't know. I just decided to start going by tens. So now we're up to 17,000. Good. You probably know where I'm going with this, but in case you're not a mind reader, let's go to 40 years. I'm going by tens now. So notice I rounded it up at the end to 26 cents because after the pennies place, your decimal says 0.25, but then after the pennies place, there's another 5 that rounds your pennies up to 6. So we'd have 26. I want you to notice something before we go to 50 years and to 60 years. This is really the main part that Sam had asked me to discuss with you ahead of time. And here it is. I want you to notice that it's growing exponentially. And what I mean by that is take a look at the difference between, focus on this up here, please. Look at the difference between years 20 and 30. It gets bigger. So the difference from year 20 to year 30 was a difference of about, what, $11,000-ish? Can we agree? Look at how much it grows from years 30 to 40. 28,000. And you know where I'm going with this. If we go now and we do it for year 50, how much is it? 85. So you guys see now that it is now grown. So 10 years is 10 years. I don't care how you slice it and dice it. But between years 20 and 30, it only grew, what did we say, 11,000 something, right? But now between years 40 and 50, it grows $72,000 in the same time period. How in the hell is that possible? Well, it's possible because if you keep taking 10% of more, you get more. And when you take 10% of that new more, you get more and more and more. It's called compound interest. It's where money goes back in and you make more money off of the money that you already made. And like Bryce said, just wait till you do 60. So let's go ahead and do it for year 60 also. Say it again. 304.
64 cents.
So now this is, well, and that's what I wanted to do with you for our last 10 minutes together today. I don't think I'll talk about growth today. I've decided what I want to do is now let's start looking at some variables that we can tinker with. I think anything beyond a 60 year is an unreasonable expectation because if you start investing even when you're 20, you don't want to be thinking about an 80-year investment. Like who's going to start pulling money out when they're 100, right? So 60 years is kind of like, that's pretty reasonable amount of time. It's a long time, but it's reasonable. So, I mean, just look at this. I mean, look at how the growth happened. So it went from growing by like 11,000 to this and this. And now finally, in our last iteration of this process, it grew by $187,000 in just 10 years. And like someone pointed out, DC said, that's just starting with 1,000. Let's go back to the beginning of the problem and let's change it. Let's say we got really, really lucky. Someone passed along an inheritance, and let's say we started with 5,000. Got it? Let's just start right at year 50. And I'm going to write these answers in blue, but again, let's start with $5,000.
And you invested in your 500. Half $1 million.
$586,954.26. Year 60, I hear, is over $1 million. Is that correct? 1.5 million? It's insane.
That's $1 million.
Right.
That's all my truck can do.
Now, one of the things that Sam will discuss with you, because this is more his area of expertise, I'm well out of my comfort zone. 10% is not to be expected. You're not going to get 10% average rate of return over the course of 60 years. It's not. Sorry to burst your bubble. It's not going to happen. But in my discussions with him, I got the feeling, and these are great questions for him, that 6% is pretty reasonable. So let's go back to the beginning. And let's just assume, let's start over with $5,000. And let's do a 6% average rate of return over the course of 50 years. So by the way, yes, good question, Kale. I'm sorry that I just jumped right to that. What this one would look like, I'm sorry, you guys, is 5,000 times 1 plus 0.06 raised to the power of 50.
You said that's over 50 years.
Anytime this number right here, Colby, is our time. So that 50 that I circled up there, that's the amount of time in this case. Right. And this is more realistically in line with what you can expect long-term on an investment. Let's do that same one. Let's do $5,000. Let's keep it at 6%, but let's go all the way out to the 60 years. Good, 164. At 60, oh, it's at what? 50 what? Oh, what interest rate are you using? What interest rate are you using? Yeah, because we swapped back to 6%. Got it?
What years did you just do?
Just did 50, and I got one. Oh, wait, I just did 60. Oh, by the way, so if you did this also at 60 years, you should have come up with $164,938,000.45. So here's what I can tell you about this. If this is something that you're interested in, because I feel like we've overcome that awkward first 9 minutes where everyone's stumbling around trying to find the frickin' exponent button on their calculator. Now that you're comfortable typing stuff in, if you're interested, there are variations on this formula that are affected by other things. Like, but let me ask you this: do you think it's realistic in the real world that someone would go drop $5,000 off and say, "Hey, peace out, I'll see you in 60 years"? What's going to happen in between then? I was more thinking optimistically, like I would like to tell Sam or someone like, hey, I plan to put $100 a month in. I plan to make regular contributions to this. And there are modified versions of this formula that take this into account. And another thing that can be modified is the frequency with which you get interest. There's no law that says you're only allowed to get interest once a year. You can get interest once a quarter, like 4 times a year. You can get interest once a month, 12 times a year. Sometimes you can even get interest compounded daily. every day. So these are all modified versions of the formula. And if you guys would like to go down any of those roads, just let me know.
So is this investing?
This is sort of the fundamental piece that goes with investing. Yes. So this is the part I wanted to get this out of the way before Sam gets here. So when he asks you guys about, do you understand how money compounds? What I want you to know about it is, if you guys, and I'm trying to stay away from the heavy duty algebra here, but let's just make believe here for a second. Ready? That we were going to graph. What I want you to see is this, that if you start your investment at, say, like $1,000, do you guys remember like 10 minutes ago or 15 minutes ago, how the first 4 years and the first 10 years, it wasn't very exciting, was it?
No.
There was some growth, but then what happened around like year 50, 40?
Jump 30.
Right. And so this is called an exponential curve. And if you look at it, it goes like
We just find out the ones.
this. And I want you to understand that. So this is why when people say invest while you're young, it's not just because they're old people like, get off my lawn. It's like, here's the deal. This period of time from here to here could be 30 years. And how much exciting stuff has happened? Not much. And so if you start investing when you're 35, by the time you're 65, you haven't given,
You're just going to be getting it.
yes, you haven't given your curve the chance to do this cool stuff. So when old people tell you invest while you're young, they're Sparky. It's not because they're old people. It's because they care about you and want you to have enough time to get to the good stuff. If you can start investing when you're 18 or 20 and keep going at it, by the time you're 60, which I know to you is like, you're going to be 60, you're going to be 65. When that happens, you're going to have so much more than your buddy who didn't decide to start investing till he was 30, right? Because you've had those extra 15, 12 years of this exciting stuff like this. So tomorrow I'm going to teach you about exponential decay, which is really easy. And then we're going to do a delta math assignment also. Yeah, decay doesn't usually apply to like money problems. Decay is more for like the value of a car or the population of a bacteria and something.